chapter 8 sample problems for the final. Let's see what we have here. Okay, chapter 8, we start with section 3 here. Section 3, question 35, evaluate the integral. We have secant 6 to the 3x, tangent 3x dx. How would you evaluate that? Let me show you a similar question, the idea how you would proceed. This is secant cube x, tangent x dx. Look, we have tangent 3x here, but we have tangent x here. The power of tangent is 1. Secant is cube here. What you do is you just separate secant squared x with secant x. You get secant x tangent x, and you're gonna say secant x is, you are gonna use substitution. U is equal to secant x, and du is equal to secant x tangent x dx. So this part is gonna be du, and this is gonna be u squared, and then you integrate it. You get u cubed over 3 as the answer, plus c, and put back in u was secant x, so you get secant cube x over 3 plus c. So we are going to do similar here as well. We are going to separate it as secant 3x, secant to the 5 3x, tangent 3x, right? Secant 3x, secant to the 5 3x, secant 3x, tangent 3x. And then we are going to let u is equal to secant 3x, and du is secant 3x tangent 3x dx. So this is going to be du, and we have u to the 5th power, and then we integrated u to the 6 over 6 and put back in what u is. U was secant 3x, and you're good to go. Okay, plus c, don't forget to write c in there. And then let's see the next question. Okay, so chapter 8, section 4, question 47. Use an appropriate substitution and then a trigonometric substitution to evaluate the integral. So we have integral square root of x, integral 25 minus x dx. Let me solve a similar question to this. Look at that. The integral we are interested in, integral square root of x, square root of 1 minus x dx, right? The question is similar, very similar. Look at that. Here square root of x, square root of 25 minus x, and here square root of x, square root of 1 minus x dx. Okay, very similar. So what we are going to say, we are going to let u to be square root of x, and x is u squared, and dx is equal to 2u du, and then we substitute what u is. This is u, this is square root of 1 minus u squared, and then 2u du, right? Dx is equal to 2 times u du. We put it in here, and then you combine the u's, you get u squared, square root of 1 minus u squared du. And then whenever you see square root of 1 minus u squared, you should let u to be sine theta, because it is remember, sine squared theta plus cosine squared theta is equal to 1. You should look at that. You can use that. U is equal to sine theta, du is equal to cosine theta d theta. So now we are this is our second substitution, right? The first substitution was this. This is the second substitution, and then be careful that this is going to be true when theta is negative pi over, between negative pi over 2 to pi over 2. Okay, and square root of 1 minus u squared is nothing but cosine theta. All right, why do we have this restriction? Because of the sign of cosine theta, because we have square root. In order to take out the square root as a positive value, theta has to be restricted to this. And then we put in the u values to use, this is what we had here. U is equal to sine theta, we put it in. You have sine squared theta, square root of 1 minus u squared. This is the trigonometric substitution, by the way. Okay, that's what they say. First do a substitution and then a trigonometric substitution. And this is what we are doing here. And u is sine theta, sine squared theta. This is cosine theta here. And du is cosine theta, d theta. We put it in. So we get 2 times integral sine squared theta cosine squared theta d theta. We complete this to double angle formulas, okay? Double angle formula says 2 times sine squared theta cosine squared theta, 2 sine theta cosine theta is actually sine 2 theta, but we multiply by 2 and divide by 2, we get 4 times sine squared theta cosine squared theta. This is the same as, this is the square of sine 2 theta, okay? And we have the 1 over 2 in the front. And then we rewrite sine squared 2 theta in terms of cosine 4 theta. This is also again double angle formulas we use, and this makes it easier now, and we can separate each term, and 1 over 4 d theta integral d theta plus minus 1 over 4 cosine 4 theta d theta. So we use the double angle formulas twice here, okay? One of them is for sine 2 theta, the other one is cosine 4 theta, okay? And then we just directly calculate. This is easy to calculate, this is easy to calculate. We calculate them, theta here and sine 4 theta over 4, and then what is next? We don't forget to write plus c here, and then we go back and rewrite everything in terms of u and then x, and then you get the result. All right, going backwards is gonna cost you a little bit too. Because be careful here, you have to open up what sine 2 theta is in terms of double angle formula, so that you get cosine theta in here and sine theta back. Okay, be careful in there. Okay, that's the end of this question 47. Let me see, what do we have here next. This is the integration by parts. We are going to talk about that next.